Hello, my name is Paul Weaver and I'm working with fellow software engineer David Honor to build a distributed audio workstation called Concert. We've got three big aims for our system: to enable you to control your recording sessions from multiple devices at once, to invite other people to join your audio sessions live across the internet, and to track changes everyone has made to a project. Today I'd like to show you some of the work we've been doing towards the first of those goals, getting multiple devices talking to a session simultaneously. I'll show you the command line output from running components of our system, and we'll hear some audio as I control playback. The first component we're going to look at is called the relay. Its job is to coordinate communication between other components of our system. It doesn't know anything about the audio application itself or the clients. It just receives events and dispatches them to interested parties. I'll quickly demonstrate that by bringing up an example client. We start the client and tell it to subscribe to audio transport events, that is, play-pause events, from our application. As you can see, the relay receives our subscription requests, but sends us an error back saying that no one is providing that API. Next, we can start our audio engine application, which actually does provide that API. When we start the engine, it immediately starts processing audio. However, we're not currently playing back anything, so it's producing silence. Its output also isn't connected to a sound card either, so the first thing we need to do is wire everything up via jack. Now we've wired jack up, we can actually hear the glorious silence that our audio engine itself is producing. The thing we want to do now is start playing back an audio file using the engine so that we can actually hear some audio. When we started the engine, it sent a bunch of metadata messages to the relay explaining its API, as well as some state messages that told the relay its current state. Now, when we try to subscribe the client to the transport API path again, we can see that it's informed of the current transport state, which is 0 here, which stands for paused. Remember, there's no user-friendly interface on top of this yet. We're just demonstrating that our components can communicate with each other. Let's go ahead and subscribe a second client in the same way that we subscribed the first one. Now comes the fun part, the bit we've been aiming for this whole demo. We want to get a client to start playback and the other client to notice that what's happened. So we've started playback and you can hear that our audio engine is actually playing some audio. Notice that the first client received an event saying that playback had started when the transport state changed. It changed to 1 here, which means playing. But the second client got exactly the same message. Both clients can tell their users that audio is now playing, and both are in exactly the same state, even though only the first client initiated the command. Of course, we can pause the audio, and let's do that from the second client so we can show it works the other way around. So notice again how each client got a message indicating a change in the transport state. So those clients are controlling the audio engine equally. Neither one is any sort of boss over the other. And those components that I've shown you today are the actual running components of our system. So there's no sort of smoke and mirrors. We are doing all of that coordination and it's all working over the network. So that's kind of what I want to show you is the first part of that first goal, to get you talking to with multiple devices to your sessions. As a bonus, this audio, the narration that I've been doing today, has also been recorded on our audio engine to show you that it's live and kicking and does some things. So hopefully soon we'll be able to show you some building on top of this. But in the meantime, go check out some of our links and our other material. Cheers, bye.